Today's episode was recorded live following the 2024 Total Solar Eclipse in Hannibal, New York. This episode and the Totality 24 Festival were made possible in part by a grant from the Simons Foundation and were both part of its In the Path of Totality initiative. The following conversation took place in between Laraaji's performance of his albums Moon Piano and Sun Piano, a brief excerpt of which will be played following this announcement. Please be sure to check out our other episodes, including one with Jeff Tweedy and a computational psychologist on the nature of consciousness. If you've not yet done so, please give us a review and some stars on your platform of choice. Thanks for listening. Welcome to Sing for Science, the show where musicians and scientists talk about music and science. I'm your host, Matt White. Each week we'll talk about a song by our guest artist and how it connects with our guest scientist's area of expertise. Today we'll be speaking with perhaps the greatest living practitioner of New Age and ambient music, Laraaji. Now in his 9th decade, Laraaji has given the world over 50 albums, including the well-known Brian Eno-produced Day of Radiance from 1980, leading up through 2020's companion albums, Sun Piano and Moon Piano. Regarding Sun Piano, Laraaji describes the piano as, quote, an instrument that gives voice to how I hold space for light, and Moon Piano, which he considers a, quote, contemplative sound painting embracing the quiet, tranquil unfolding of nurturing reflection. Also joining us is Cornell University Astronomer Dr. Nikole Lewis. Dr. Lewis is an expert on the understanding of exoplanet atmospheres. Exoplanets are those planets that orbit stars outside our solar system. She has successfully bridged the gap between exoplanet theory and observation through her pioneering work with Hubble telescope images and the development of atmospheric modeling tools. Dr. Lewis joins us today to talk about the science behind a total solar eclipse, the phenomenon during which Earth's only moon perfectly blocks out all of the sun's light. The title of today's episode on the podcast is Sun Piano, Moon Piano: Understanding Cosmic Coincidence in the Sun-Moon-Earth System. Hello, Laraaji and Nikole. Thank you for coming on Sing for Science.
Hello.
You're welcome, Matt.
Yes, thank you.
So I myself am a musician, and it's perhaps always the most interesting to me to speak with instrumental composers about their inspiration. Because talking to a lyricist, can be, somewhat straightforward to say, what's that song about? So in this instance, you have absorbed this experience and you transformed that and also ideas about the moon into tones on the piano. So how does that happen?
This way, spontaneously. So I feel the moon is feminine, water, space, quiet, silver, and so I visualize space as silver, liquid, feminine, and with the piano as a tool of touching, caressing, interacting within my imagination field. And what evolves is a spontaneous piano voicing of this reflection. So it's imagination. Einstein said, logic will take you from A to B, but the imagination will take you everywhere. And so I use the imagination of my imagination of moon energy.
So when you're actually translating that into representing it in 12 notes, for example, there was one really beautiful moment when you're playing in the upper register, and I can't expect you to recall everything that happened in that 30-minute performance. But for example, when you go to a high register and you're representing the moon, are you able to describe that process of composition or intuition, what you're trying to translate through tones?
I don't know.
I'll take it.
My favorite visualization is that this is all clear. There's nothing and there's no one here, not even this body. There's total clearing. And imagine that the total resolution, no emotional congestion, no mental confusion, no physical conflict. And to let that or this image dance and move and glide. And to me, it feels maternal, nurturing. So the moon out there, I think the moon is nurturing energy. Feeds you. Does the moon feed you? Matt?
Does the moon feed me?
Yes.
I think in a sense.
Yes?
Yeah.
Mm-hmm.
It's reflective.
Yes. My apartment in Harlem, at night, I'm looking up through my window and there's the moon. Mm-hmm. The moon's always peeping down through my window. I said, how is it that my apartment is situated that I'm always getting the moon energy? So I have this kind of soft relationship with the moon in the sky. And been doing research on the moon.
How do you describe that?
Supposedly there's some interesting information about the moon. The moon is not what we think it is.
Do tell.
Yeah, that's you should do some research.
Okay. Will do. I was listening to you on Mark Maron. Laraaji was on the insanely popular WTF podcast. And so I learned all these really interesting things about your biography. So for my own, to satisfy my own personal curiosity, I wanted to talk a little bit about your history studying composition, because that's how this all started, right?
The history of...
You having studied composition at Howard.
Studied theory and composition of music.
And that was in the 60s at Howard.
Yes.
So
Howard
is that
University.
classical?
It was classical based when I was in the classroom, but when I was in the practice room, it was jam based. It was jazz and exploratory. But I learned under a classical model, classical music, which gave me an appreciation for classical chords, patterns, rhythms, and composition. And so now it allowed me to spontaneously create with a composer attitude.
Mm-hmm. This may represent a very sharp deviation from what we're here to talk about.
Oh, let me turn then.
So, I'm no student of history, but know a little bit about Howard during that time period, having read Howard Zinn wrote a book about the Student Nonviolent Coordinating Committee. So, which in a sense was kind of birthed there in some manner. Stokely Carmichael, was he there at the same time as you?
He was there. He was laying down in front of tanks and things like that, and protesting. I was just sort of watching at the side of my eyes, wondering what this was all about. Because I wasn't about to lay down in front of a tank, but he was on campus and he was pretty vocal and pretty firm, and though impressive figure. Stokely Carmichael.
So, but that was like a visible part of daily life on campus then?
What?
Like freedom rides, SNCC, those kinds of protests?
That happened for a period. It rose up for a period. It didn't swallow up my whole experience of Howard.
Yeah.
You know?
But so you're studying composition there, and then how does it make the turn into playing ambient music? I can
it
do.
prepared me. It prepared me to be a channel, to channel exquisite music. Also, meditation prepared me to channel exquisite music. All the music that I thought I had to read on somebody else's music score was waiting inside of me to be released.
And so I've read that it was through a meditation practice that this concept of sound vision revealed itself. Do I have that right?
An actual experience of sound, having a sound vision. In other words, having a total experience, languaging itself as a sound, a total cosmic field, multiple layers of brass instruments. And the communication was the nature of eternity as being now, and that everything is going on this moment. Of course, when you look through eyes and you listen through stereo ears, you can paint a picture that there's a stereo field going on here and there's distance between this body and that body. But this music imparted a vision of there is really oneness. There's a way to be so present that you see and feel and act oneness. And that gave me a new model for what I wanted to do with music myself, is to point to, it's actually this space, but point to that space with sound. It's sort of like a little child watching their mother and father do something, and I want to do that too. So when this sound came and showed me how you could feel eternity and feel oneness, I said, I want to do that too. And I didn't know how I was going to do it. So it was revealed to me a little later on how I was going to do it. But I'm not going to tell you.
Okay. I won't ask. So an experience like today's, watching the eclipse, as I'd stated, I'd know you got several offers to play, at eclipse-related events, yes?
Yes, I did. I was invited to be in Bali. There's no eclipse there.
It's just a coincidence. Yeah.
And then the one in Texas, I think, somewhere along the path.
Okay.
Yes.
So,
but you jumped on the ball 5 or 7 months later before I knew that there was an eclipse coming.
Yeah, exactly. So, I guess my question is, there's an association between the kind of music you make and an event like today's. Does it carry special meaning for you? Have you experienced one of these before?
It does, because you agreed to pay me.
Very true. Yeah, okay.
Yeah, but it does have, because I'm curious about why is this going to affect anything? If you look at the sun and, there's the moon blocking the sun, and what is the moon thinking? What are the people doing down there?
Well, this is our opportunity to make a very fluid transition to the science portion of the show. So I guess, Nikole, the first thing I want to ask you, because I know that a startling number of coincidences have to take place for this to happen, and assuming it happened on a brilliant, bright, clear day, we would see that. So I was hoping, for starters, you could kind of enumerate what all those things are.
For a total solar eclipse to occur. I mean,
Yes.
I think it's important to remember that the Earth is very unique. The Earth-Moon system in particular. We have neighbors, Venus and Mars, and they don't have events like this. Venus doesn't have a moon at all, and Mars's moons are tiny little potatoes that barely block out the sun from that distance. And so our system is very, very special in that our moon, when we look at it in the sky, that when you look at it from Harlem and you're looking up, it has a very particular, what we call angular size. So it has a certain extent on the sky, and it's the same angular size as the sun in our sky. And so it just happens that, the sun and the moon are not the same size. The sun is much, much bigger than the moon, of course. But we're at just the right distance such that they can eclipse each other. And so for a solar eclipse to occur, we need something very special to happen with this alignment. We need the moon to pass between us and the sun, but it has to happen along what we call these nodes in our orbit as we go around the sun. Turns out that the moon is actually on an orbit that is what we call inclined. It's tilted, sort of. And so as it's going around, it can pass between us and the sun, but it could not block the sun's light. And so the rarity with which these events occur is because of the design of our system. And it's something that's quite beautiful that we've not seen in other systems.
So what, I mean, because the deal is that it's like exactly the same distance. I'm going to totally blow this,
All right.
so you go ahead.
Again, if the moon were, say, farther away from us than it is right now, it would appear smaller in the sky.
Right.
And it wouldn't block all of the sun, right? And so the fact that it's exactly at the right distance and it's exactly the right size means that it can actually block out the sun's light entirely.
And that's all the time that relationship happens in ratio anyway.
For our system, yeah.
Yeah.
You know, the moon is about a half a degree size in the sky, and the sun is a half a degree size in the sky. And that's just how our system is set up.
Is your math sharp enough to talk about what the odds are of that happening?
So, I mean, the odds are actually quite small. Now, eclipses do happen in other parts of the solar system, mostly for the big gas giant planets out there. They have lots of moons that are flying around them, and actually the sun appears smaller in the sky. So the farther you get away from the sun, the smaller it looks in the sky. And so for the gas giants, they have eclipses happening all the time. But for us, again, where we are in our distance from the sun, this perfect distance that makes Earth, in fact, habitable, we can have liquid water. It means that the exact distance of our moon from us and its exact size is able to cause this event.
And one thing I noticed, my wife pointed out to me that at any time during the year, we both kind of have a good sense of where the sun is going to be, but the moon is a real mystery. So when you're saying you can look out the window, do you have a sense of where the moon's travel path is going to be, or do you have that same relationship with it that you do the sun?
I know it's peeking through my Harlem windows, so I have a feeling of is a trajectory, the moon trajectory. Yes, it's more present than I expected to be. I'm suspicious that it's trying to communicate with me.
Do you have any comments on that?
Yeah, I mean, the moon is, of course, on basically a monthly cycle. I mean, that's where we get, our months, right? And so as it goes around, we see, of course, the different phases. And what we experienced here, you can only have if you have a new moon, right? And you want the moon and the sun to be on the same side. Now, you can still see, sometimes you see the moon during the day, right? Have you seen the moon during the day from your?
Yes.
Yeah. So, sometimes we can see the moon during the day, and it's just the reflected sunlight that we're seeing. And so it just happily goes along its 28-day orbit on its slightly inclined and slightly eccentric, actually, orbit. And that's what gives us what we see in terms of patterns in the sky, both in terms of the moon's phases and when we can see it.
So because you study exoplanets. Did I
do,
get that right?
yes. I'm trained as a planetary scientist, so I also study planets in our own solar system, too.
You do?
Yeah.
Okay. So is what happened today an opportunity to do the kind of research you do?
What we see today is actually an opportunity for me to think about the implications of events like this that might occur in other planetary systems. It's also an opportunity to try to study our own atmosphere in a couple of different ways. So there's two great things that I'm getting from the eclipse today, and that's thinking about, well, first of all, we haven't seen any Earth-Moon-like system around another star yet, and so how unique is this setup? And then also thinking about how the sun's light actually affects our atmosphere. The sun's rays actually change the chemistry, change what our atmosphere is made up of, and causes all sorts of interesting processes that I'm interested in studying both here and then around planets around other stars.
What are those processes?
Yeah, so the sun's light, I mean, we see in what's called visible wavelengths, we see color, right? Colors of the rainbow. Our eyes are attuned to those colors because that's sort of the peak of where the sun's light is emitted. But the sun actually emits light in many, many other wavelengths, including the ultraviolet and the infrared as well that we can't see, X-rays as well. And so ultraviolet is actually very important for driving what we call photochemistry in Earth's atmosphere. And that gives rise to things like, say, the smog over the LA basin. So, and those processes are actually quite important for the way that our atmosphere has evolved, and potentially also important for the evolution of life. Actually, some of those chemical elements could have been some of the seeds for life here on Earth.
Like we did an episode on cyanobacteria, which is influenced by light.
Right. And so I don't know if you've ever heard of the Miller-Urey experiment, where basically what they did is they put sort of like a bunch of stuff that you think is important for life in a can. Okay. And then they applied some very high energy. They actually sort of shocked it. But that's sort of what ultraviolet light does. And so during that process, they were able to create these what we call chemical precursors to life. So sort of like amino acids that could then exist in their little can. And so we think that those processes and the construction of amino acids could have been driven in part by some of the chemistry in our atmosphere.
This was recent, right? Somewhere?
Oh, Miller-Urey was a long time ago, actually. Well before my time. It was, I want to say, in the 60s. And Carl Sagan actually did some very famous similar experiments trying to understand the atmosphere of Titan, one of the moons of Saturn.
Okay. Yeah. And this was something I want to talk about because Carl Sagan, he taught at Cornell.
He did.
And so you work at the Carl Sagan Institute.
I do. I'm part of the Carl Sagan Institute.
Okay.
We're an interdisciplinary group of researchers, so it includes professors, researchers, students as well. And all of our research sort of intersects on trying to understand how life might form and evolve on planets beyond Earth.
Oh, wow. Mm-hmm. What can you tell us about that? I didn't know that.
No, okay. Right now we're still at the beginning. In the solar system, I think we have a few, obviously life exists here. This is our singular sample right now. We've had lots of robots on Mars that have been digging around looking for possibly prehistoric life or maybe some signs of, microbial life right now. Out in the outer part of our solar system, we have lots of researchers who are studying what we call icy moons that have these global scale oceans underneath these icy crusts, and we think that life could have evolved there as well. Beyond the solar system, what we're trying to do is understand what made Earth so unique that it could support life like us. And so we're looking for signatures of atmospheres that are like us. We're also trying to understand how those, properties of the star, so how ultraviolet light might affect the evolution of life in other solar systems. And so we're using a lot of what we understand in the solar system to then try to understand the context in other solar systems.
So where are we at with that, with the understanding?
So, in the solar system, we are starting to see hints of, again, amino acids and those sorts of things in some of these icy moons. We have actually one of the moons, again, around Saturn, actually spurts a bunch of stuff into space. And one of the spacecraft that we were able to send out there was able to collect some of that material and then analyze it. And it does look like it has some of the precursors for what we would consider as amino acids. We're also sending, I like to call it a quadcopter, but it's basically a drone to Titan, which is, again, a moon of Saturn, that will actually take samples and try to understand if there's microbial life there. Now, in terms of planets beyond our own solar system, we're just now scratching the surface. We do know of, I guess, more than 6,000 planets around other stars, and we know some that are roughly the size of Earth and roughly at the same distance from their star that would give them sort of nice conditions, not too hot, not too cold. And we're beginning to try to study their atmospheres to see if those atmospheres have what we call signatures of disequilibrium. Okay, so the chemistry of their atmospheres is actually messed up because there's life. So we actually create disequilibrium in our atmosphere.
Yeah, well, that's not shocking.
No. Well, yes, not shocking, not in the context of global warming and all the other sort of stuff that we do, but we also just, in the trees living and us living actually affect the chemistry in a way that is discernible, that we could try to measure in a different planet.
Okay. What was Carl? I mean, because Carl Sagan was one of the first to help, one of the great science communicators. Mm-hmm. Is that? I guess my first question is what were his views on extraterrestrial life?
I think his views were that, as many of us share, that there certainly must be life out there. Yeah. And that we should put a lot of time and energy and resources into trying to find that life. That was a big driver for him. And in particular, part of the reason why he was so interested in studying the moon Titan around Saturn. It is entirely possible that their life exists, maybe not as we know it. And I think that was the other big thing with Carl Sagan, is that he constantly wanted to challenge sort of the norms of how we think about life and how we think about the exploration of space and what that means.
I mean, that's not surprising. I interviewed Brian Cox, the physicist, the English physicist, a couple weeks ago, and he kept quoting Carl Sagan throughout. And one thing that he brought up was having gotten picked up from the airport in New York, picked up by the taxi driver, and he was recognizable as a television personality. And the taxi driver kept wanting to ask him things about Atlantis and things that are usually relegated to like conspiracy theorists or pseudoscience or what have you. And he made the point of saying that people like him need to be defended because they're curious, you know? And it just seems like that's, to me, what makes him such a great communicator, that he's able to bridge that.
Yes, and that's another part of the mission of the Carl Sagan Institute is sort of this public outreach and getting people interested and excited about science, because science is for everyone, and I think that's the important thing to remember. It's not just for me. It's my day job, which is great. I love being a scientist, but everyone here is a scientist and should engage in that practice.
Excellent. And it's his 90th birthday this fall.
That's right.
Your 90th?
No, it's not my 90th birthday. Yes, we're going to have a celebration at Cornell this fall.
In Ithaca.
Yeah,
okay.
in Ithaca.
Okay, very good. So we have both of our guests have been generous enough to allow for some brief Q&A. Does anyone have a question for either Dr. Lewis or Laraaji? Elia. Nice and loud.
Dr. Lewis, you shared your thoughts on life, the potential for life in outer space. Laraaji, what do you think is out there?
Nothing. I feel it. I feel there's one life current everywhere. Where the conditions are right, it will individualize and externalize. There's talk about a planet named Keller. Have you heard that? That there's probably a planet called Keller, a couple of light years to get there, a big Uber charge. But my feeling is that there's this one life current, and I don't think there are other lives. I think there's one life. I feel there's one life, individualizing. I could say it has to be, wherever the conditions are right, that this one current can individualize there. And it doesn't have to be a carnal electromagnetic carbon-based body. It could be a light body, it could be a tone body, a non-human form. We were talking about life animation, self-aware's animation. That's what I feel.
Okay. Any other questions from the audience?
Well, mine is not really a question, but I want to know what you think about this.
Could you say just a little bit louder?
It's not a question.
Yeah.
Just I want to share this with you, and I want to know what you think about it. So maybe there is no an extraterrestrial, alien living anywhere, but we were able to, as humans, go outside of our planet, and done that. Maybe we are going to bring life outside of this planet. So, what do you think of that future, us taking life outside?
Like colonizing Mars or something?
No, just the fact that we are able to go outside, we can bring life outside, and that life may be the ancestor of future aliens, future species.
You have thoughts?
I can start. So, I mean, panspermia is basically, I think, what you're describing. And in fact, there are thoughts that life came to Earth maybe on an asteroid, or a chunk of Mars came in. And that's where those sort of starting seeds for life came from. And this is actually a big part of the recent OSIRIS-REx mission that went out to an asteroid and dug into it and then brought back a whole bunch of material so that we can see actually what that material is made of, and maybe if that's a place where you could start to have some of these life precursors. I will say that, when we do send spacecraft, say robots to Mars, we're very careful to, through what we call planetary protection, to make sure that they are not taking anything with them. And recently with the Cassini mission, we dove it right into Saturn's atmosphere for the same reason, planetary protection. So we are worried about us inadvertently sending microbes out into space, but it's also possible that we are just the ancestors of microbes that arrived here at an earlier point.
Was there anything conclusive discovered from that mission you described where they dug into the asteroid?
So OSIRIS-REx just recently came. I actually, last semester, I got to teach a lecture on the day that they sort of uncovered the sample. It was very exciting. I just let everyone watch NASA TV for the day. They didn't mind. So they're still studying that very, very carefully. It does look like there was plenty of water and a lot of carbon, and so there's all these sorts of seeds where you could see that you could start to assemble the sort of building blocks of life.
Splendid. Any more questions? Yes.
Do you think there was any correlation with the earthquake that came with the eclipse?
There is tidal forces that occur, of course, between the Earth and the Moon. I don't think there was probably a strong correlation. I don't think it was part of our tidal flexing that gave rise to the more recent earthquakes, I guess, that happened in New Jersey. Yeah. But that is something that we do need to remember, is that our moon is a dynamic body that's pulling on us at all times. So
That fascinates me. How the moon actually pulls on something.
yes, gravity, it's everywhere.
So it pulls on the water.
That's right. So it's actually, this is always a concept that when I teach it in Astronomy 101, which is actually the course that Carl Sagan taught way back when, but now I get to teach it. We talk about how tides occurred. And one of the things that always confuses people is when you look at where, say, high tides is, it's on one side and the opposite side of the planet. And the reason that is the moon will be on one side, but there's actually what we call a differential or a gradient in the gravitational force from the moon across the planet, and that's what's giving rise to those tides. And so it's not just the side that the moon's on that has the high tide, it's actually also the opposite side as well.
Where there is no moon.
Where there is no moon, that's right. That's the power of gravity and the fact that there's a little bit of difference in gravity between one side of our planet and the other, just where the moon is.
Aha. Right.
I can give another good example. So Jupiter has lots of moons around it, and one of them is Io, and it has lots of volcanoes spurting around, and all of its cousins also tug on it, and so it gets tugged on so much that it actually causes these volcanic eruptions to happen. And so we see tides are an important part nearly in all of our planetary systems, so that it's not just unique to the Earth-Moon system, but we of course see it as the rise of the water tides, but it's an important process that we see in many planets.
Okay. We have time for one more question, okay? You in the back?
I don't really know how to say this question, but is there any known effects that an eclipse is having on your body, or is it is your brain being confused about its circadian rhythm or something where it doesn't understand that it's getting dark so fast, or is it pulling on your blood? Because we all just felt very strange. I don't know if you can say anything.
Would you like to go for? How did it make you feel? I guess.
I was curious. I was waiting to feel something, and when the cloud says, "Not now," I thought, well, here we are together in a collective intention, and so I felt good that we were brought into this greeting of unified focus.
Yeah, I mean, certainly from a circadian rhythm point of view, and they've seen this with animals. And I don't know if you all heard the peepers, the little frogs. When it started to get dark, they're like, it's nighttime, right? And so, the animals are, we of course are beings who can think about these sorts of things, but, the change in the brightness of the sky will affect us the same way it affects animals.
Okay. All right. Well, thank you so much. Please help me give it up for Dr. Nikole Lewis. And Laraaji.
Thank you. Thank you.
Stay up to date with Laraaji's future appearances at laraaji.blogspot.com. And you can learn more about Dr. Lewis's work at nicolelewis.space. Sing for Science is co-produced by Talkhouse and made possible in part by a grant from the Simons Foundation. Our music is by Panoram. Social media manager is Bailey Constas. Digital producer is Keenan Cush. And today's location sound engineer was Josh Russell. Special thanks to Gabby Gauger, Karen Thompson, Heather Grant, and Molly White for their help with today's show. If you like this episode, the best way you can support us is to give us a review, tell a friend about the show, and subscribe on your podcast platform of choice. For more information, please go to singforscience.org and follow us on social media at Sing for Science. Thanks for listening.